Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ahmad Shafiq and my metric number is J22A0212. So we're going to introduction an essential component of engineering, research and failure analysis in material testing from the basis for guaranteeing the dependability and security of material and a range of application. Engineers and research can determine the precise mechanism leading to material breakdown by identifying failure modes and comprehending their underlying cause. This information is crucial for creating better designs and material, increasing efficiency and averting mistake in the future. Engineers can strengthen durability and performance by implementing remedial action and design adjustment based on true analysis of failure. Failure analysis also stimulates innovation by expressing flaws and directing the creation of stronger material. In the end, this procedure not only protects public safety but also enhances economic efficiency by lowering expense related to unplanned malfunction and downtime. So we move to common failure mode. So for the first point is fatigue. The description occurs due to repeat second loading. As example, aircraft wings and engine components develop cracks over time due to the stress of takeoff, flights, and landing cycles. For the second point is fracture. For the description is sudden and catastrophic failure often caused by flaws and stress beyond the material strength. For the example, glass window shattering from impact or pressure and bitter ceramic breaking under hard stress. And then we move to the third point is corrosion. For the corrosion is the description is gradual degradation of material through chemical reaction often involving moisture and oxygen. As example, rusting of steel structure like bridge and pipelines, leading to weakening and potential leaks. Then point number 4 is wear. The description is erosion of material surface due to friction and mechanical action. As example, automatic brakes pads and engine parts wearing down over time, necessitating regular replacement. And number 5 is grip. The description is slow, time dependent deformation under constant stress typical at high temperatures. As example, turbine brakes in jet engine deforming under prolonged high temperature condition affecting performance and safety. So that's it. Thank you.
Alright guys, and my name is Sangamitran Analaki Velu and my metric number is J22A0243. Today I am going to present you about testing techniques in different types of materials. So there are 5 types of failures in different types of material. For the first is tensile testing. It measures material strength and ductility. The failure mechanisms that identified was yield strength, that point where material begins to form plastically. So the second one is impact testing. The purpose is assess material toughness and impact resistance. Failure mechanisms identified was brittle versus ductility. So the third one, hard testing. It determines surface hardness and resistance to indentation. The failure mechanisms that identified was surface deformation. Hardness correlate with resistance to wear and surface deformation. And the fourth was non-destructive testing, NDT, evaluates material integrity without causing damage. The failure mechanism that identified cracks and fracture, detects internal and surface cracks. Okay, now moving on to steps that taken to identify the failure cause in the case study. There was 5 steps that have been taken. So the first one is TGA. Use TGA to analyze the thermal stability and composition changes in the material under different temperatures. So the findings assess the thermal degradation was not a primary factor in the failure but helped to understand the material's behavior under varying environmental conditions. The second, initial investigation, conducted a site inspection to gather physical evidence from the collapsed structure. For the findings, note that the failure initiated at a single point on the bridge. So the third one is OM, optical microscopy. Utilize OM to visually inspect the surface and structure of the collected IBA samples. For the fourth one is SEM, scanning electron microscopy. Perform SEM analysis to examine the detailed microstructure of the IBA material. For the fifth is FTIR. Conduct FTIR to identify any chemical compounds or corrosion products on the surface of the IBA. The finding is detected specific chemical signatures indicative of corrosion, confirming the presence of stress corrosion cracking. Thank you.
Hi everyone, my name is Harmat Saida binti Gilang Pastaka. My matrix number is J22J0034. So today I will be presenting the root cause investigation in the Silver Bridge case study. The root cause in the Silver Bridge case study collapse involved a systematic approach using various methodologies. Initially, failure mode and effects analysis (FMEA) was employed to identify potential failure modes with stress, corrosion, cracking, and metal fatigue emerging as primary concern. These were prioritized due to their severe impact on the bridge safety. Fault tree analysis (FTA) was then used to create a detailed fault tree diagram, tracing the failure to a specific point on the I-bar, confirming stress corrosion cracking as the root cause. Additionally, process mapping was conducted to analyze the bridge maintenance and inspection procedures, revealing significant deficiency. These routine inspections were found to be inadequate, allowing the critical crack to develop unnoticed over time. Combining these methods provided a comprehensive understanding of the factor leading to the bridge catastrophic failure. Next is the preventive measure based on the Silver Bridge case study. Based on the findings from the failure analysis, several preventive measures were recommended to enhance the safety and durability of the future bridge. First, selecting materials resistant to stress corrosion and fatigue was crucial, ensuring that bridge components could withstand harsh environmental conditions and repeated loads. Design modifications were also suggested, focusing on reducing stress concentration and improving load distribution by reinforcing critical elements like I-bars. Additionally, the inspection and maintenance protocols for bridge were significantly improved, incorporating more frequent and thorough checks to detect early signs of wear and degradation. Rigorous quality control measures were implemented during the manufacturing and assembly of bridge components, ensuring that only high-quality materials were used and initial defects were minimized. These preventive measures aim to address the identified root cause and prevent similar failures in the future.
Assalamualaikum and very good morning. My name is Muhammad Farizal Hasmi bin Muhammad Farid Inyo. My number matric is J22A0067. Today I would like to talk about collaboration with industry. Okay, my first point is sharing knowledge. The benefit is shared finding from the Silver Bridge collapse with the engineering community to improve bridge design and maintenance practice industry-wide. Next, my second point is accessing real-world data. The benefit is use data from similar bridge and structure to understand common failure, modes and conditions. Enhance overall safety protocols. Okay. My last point is learning from practical experience. The benefit is applied lesson learned from the Silver Bridge collapse to develop new standard, new and regulation for bridge construction and maintenance. Thank you. Next is conclusion. First, importance of systematic analysis. The case study demonstrated the effectiveness of FMEA, FTA, and process mapping in identifying the root cause of the collapse, emphasizing their importance in failure analysis. Second, implementation of preventive measure. Highlight the need for appropriate material selection, design, modification, process improvement, and stringent quality control prevent future failures. Third is collaboration with industry. Showcase the benefit of sharing knowledge and data with the industry to enhance failure analysis practice and improve engineering standard. Four, continuous learning and improvement. Reinforce the necessity of ongoing education and adaptation in material engineering, using the Silver Bridge collapse as a learning opportunity to advance the field and prevent similar tragedies. Thank you.